circulation in whom do we see double circulation? We see in all the animals who have a four-chambered heart. Okay? So who are the animals? But mammals and crocodiles. Okay. Okay. Now imagine if there are only two chambers. What will happen? If there are only two chambers, instead of four chambers, what will happen? Okay, deoxygenated blood always starts from the tissue. Deoxygenated blood here, deoxygenated blood from the tissue will go to the heart. Okay? From the heart, deoxygenated blood only goes out. Understood? Deoxygenated blood enters the heart and deoxygenated blood leaves the heart. Okay, then why you need heart? Again, same pumping action. You want to provide the pressure. We are living on the third floor. नीचे से पानी कैसे आता है? पंप है ना नीचे. तो पंप ऊपर पानी चढ़ने के लिए पंप चाहिए. वैसे हर एक सेल तक कुछ भी पहुंचने के लिए प्रेशर चाहिए. That pressure is provided by the heart. Okay. So blood goes inside the heart. Deoxygenated blood leaves the heart and then goes to the gills. Gills is the organ of, they are the lungs for the fish. So they are the organ of respiration for the fish is the gill. Okay. Once that this blood goes to the gill, it gets oxygenated, and the oxygenated blood from the gills then goes to the different tissues. Okay. So this is single circulation. There is only one single circulation. Look at this. It will come in the next slide. The next slide will be only of fish. So it is single circulation. Double we've already seen in human beings. What is incomplete double now? Imagine there are two atria and one ventricle. Same funda. Okay? Yeah. So let's again start from the tissue. Okay? The deoxygenated blood is going to the right atrium. From right atrium it is coming into the right ventricle. Idhar chhod do. Okay? The oxygenated blood by pulmonary veins is coming to the left atrium, like in human beings. From left atrium it is going to the left ventricle. Here the two bloods are getting mixed. Right से क्या आया है? Deoxygenated. Right side deoxygenated. और left से क्या आया है? Oxygenated. This ox and deox bloods are getting mixed. And the mixed quality blood is going out through a single artery from the single ventricle. Okay? So mixed blood and that artery finally divides. Yes, it will go to the lungs for oxygenation again, and it will go to the tissues for peripheral supply. But what happens in the heart is mixing of blood because ventricle is the same. Okay? So let's see this in detail now. So this is how, see, this is the systemic circulation. These are the tissues. Okay? These are the tissues. What happens? Deoxygenated blood enters the heart and deoxygenated blood leaves the heart. It goes to the gills for oxygenation. In the gills, this blood gets oxygenated, and oxygenated blood will leave the gills and go to the tissues. So one single circuit is there. So this is fish circulation. Fish, what you want to know? Single circulation. One loop is there. How many chambers in the heart? Two chambers. What are the names of the chambers? One atrium, one ventricle. Upper chamber is called as the atrium and lower chamber is called as the ventricle. Atrium is the receiving chamber always, and ventricle is the distributing chamber. Okay? So one atrium, one ventricle. What blood enters the heart in the fish? Deox or ox? Deox. And what blood exits the heart? Deox only. From where it goes from the heart to the gills. It will get oxygenated in the gills. And oxygenated blood leaves the gills, and by the way of a systemic artery, again called over there as aorta, it goes to the tissues for needs, for use. We need oxygen, that way fish also need oxygen for all their activities, locomotion, eating, all that, reproduction. So all the tissues, they will require oxygen. Okay? So these are the body tissues. Okay? So it is seen in fishes, heart receives impure blood only, venous heart. So it is called as a venous heart. This terminology is not used in NCERT. You can ignore this. But since the heart gets venous blood and blood leaves the heart also, the entire heart is called as venous heart. Okay? So this is the circuit. The circuit you all should know. Deoxygenated blood to the heart, deoxygenated blood going out of the heart to the gills, then oxygenated blood to the body part, and from the body part again this cycle continues. Deoxygenated blood back to the heart. Everybody clear? All of you must have understood two circulations by now, double and single. Okay? We will revise again double also in the end. Now, incomplete double. Now see, this is almost like the human. These are the tissues. From tissues what starts? Deoxygenated blood goes to the right atrium. Okay? From here it goes to the right ventricle. This is blue and this is shown purple. Why? Because it is mixed blood. Okay? Then from here the pulmonary veins are carrying oxygenated blood to the left atrium. From left atrium it is coming down and it is coming into the common chamber or the common ventricle. Because it is mixed, it is neither blue nor red. I mean, as far as my math is concerned. Okay? This is mixed blood. So it has less oxygen content, but not so less like deoxygenated blood. Okay? And this mixed blood is then leaving by a common artery, and this common artery now divides into the pulmonary artery which goes to the lungs for oxygenation, and a systemic artery which goes down, which is called as aorta, which goes to the tissues. So this is seen in amphibians and reptiles. Okay, reptiles only have one rudimentary septum here, Viche. Okay, but it is functionally, is it upon use? No. It is, the mixing of blood will happen or not happen? It will happen any which way. So it is seen in amphibians and reptiles. The left atrium receives oxygenated blood from the gills, lungs or skin. Now this respiratory organ can be different based on which organism you are talking about. Okay? So it can be gills, it can be skin in case of frog, it can be gills for a tadpole. Okay? It can be lungs, frog also has lungs. So it can be lungs in an adult frog. Okay? In a salamander it can be lungs. So whichever amphibian we are talking about. For a reptile it can be, they also have lungs. So they can have a lung. So all of them will, the respiratory organ will differ, but circulation, the circuit will not change. So let's look at the circuit. Left atrium receives oxygenated blood from the gills, lung or skin, that is the respiratory organ. Right atrium gets deoxygenated blood from the body parts or tissues. However, they get mixed up in the single ventricle. Ventricle pumps out dash blood. Mixed blood. Neither oxygenated nor deoxygenated. Understood? So this is incomplete double circulation. Incomplete double circulation. This is evolution. As the mammals, as the organisms have evolved, more and more specialized tissues have been formed. Like we have so many glands. Okay, there is one endocrine gland in lower vertebrae. We have so many, for different functions we have different. For carbohydrate metabolism we have insulin coming from the pancreas. For protein metabolism we have anabolic steroids coming from the adrenal cortex. So it is more and more specialization, it is more and more evolved organism. Okay, that is why we developed a septum over here and we have a four-chambered heart. But a frog, bichara, does not have a four-chambered heart. And a fish has only a two-chambered heart. And a sponge doesn't even have a heart. So that is how we have evolved. Okay? Some of them have heart but no, like a cockroach has a heart but no blood vessels. Okay? So this is about now double circulation. We've already done this. I like to teach that before because unless you understand double, you cannot understand single. But we revise double. It is seen in birds and mammals. Right atrium receives deoxygenated blood from the tissues. Okay, it passes on to the right ventricle. Left atrium receives oxygenated blood from the lungs. It passes to the left ventricle, and ventricle pumps it out separately without any mixing up. The right ventricle is pumping out dash blood, oxygenated or oxygenated. Left ventricle is pumping out dash blood, oxygenated or oxygenated. Okay. Left atrium is getting dash blood, oxygenated. Left atrium. Yes. Yes. Right atrium. Systemic veins are carrying dash blood. Systemic artery is carrying dash blood. Pulmonary vein is carrying dash blood. Pulmonary artery is carrying dash blood. Pulmonary vein oxygenated. Pulmonary vein from where to where? Lung to heart. Vein है तो हार्ट लंग में लंग से हार्ट को जा रही है, हार्ट से लंग को आ रही है, लंग से हार्ट क्योंकि वेन है. हाँ तो लंग से निकल के हार्ट में आ रही है तो ऑक्सीजनेटेड रहेगी ना. लंग्स का काम ऑक्सीजनेशन ही है ना. Okay, so if you get stuck up also use the logic. But remember these terminologies, three terminologies: systemic or pulmonary, oxygenated or deoxygenated, and artery or vein. In these, whatever 6 words, the entire circulation is fitted. Understood? And then comes the chambers of the heart. So right atrium, right ventricle. Now by only the right atrium it comes. That we will see in detail when we do the heart structure. Okay? So now, lovely heart, beating heart. Valentine's Day is just over. Human circulatory system. Okay? Blood vessels and the heart. So human circulatory system. First is the blood vascular system and the lymphatic system. Lymphatic system will study in the end. It's a very small part in this chapter because there is an entire chapter in class 12 of immunology in human health and diseases where you will study lymph nodes, lymphatics, lymph organs. Here they have just introduced and left. One small paragraph is there of lymph. Okay? So lymph, lymph vessels and lymph nodes, park it for the end. Concentrate over here. Blood vascular system. We have the heart, we have the blood and the blood vessels. Heart से निकलते हुए blood vessels. We just said arteries are the vessels which leave the heart and veins are the vessels which come to the heart. Okay? And blood is the fluid. The medium, the transporting medium is the blood. Okay. What does blood have now? Plasma. Plasma is the liquid, the fluid matrix. Okay? The solvent, which is plasma, and the formed element. See? The suspended cells in the plasma. Okay? So blood has the plasma, which is the liquid component, which is the fluid component, and the cells which are dispersed in the plasma, which are the formed elements. Blood vessels are arteries, veins and capillaries. Okay? Now arteries are the vessels which leave the heart. The arteries will become smaller arteries. Smaller arteries will become finally arterioles. And the last stage what you will get are capillaries, which are the smallest, finest vessel in the body. Okay? The capillaries will again unite to form venules. And these venules into larger veins, bigger veins, and finally these veins enter the heart. Okay? So we have heart, arteries coming out. From here, small, then capillary network, which is the smallest capillary, smallest vessel in the body. Single layered wall. We will see when it be circle structure of capillary. And then venules, veins, back to heart. Okay? So these are the blood vessels. Plasma and formed elements we just saw. In the formed elements, we have RBC, WBC and platelets. In school 6th, 7th standard we are seeing these are 3 cells in the blood. RBC, red blood cell, WBC, white blood cell, platelets are the cells, actually a cell fragments which are required for coagulation. RBCs are called red blood cells because they are red in color. Okay, true or false? RBCs are red in color. True. WBCs are white in color. False. WBCs are colorless. Okay? So, remember this also comes as true and false. WBCs are colorless. It's there. Honey, don't search. It's there in the when you describe WBCs. They are colorless cells. but you are so engrossed in that mood of the exam, white blood cells are white in color. Yeah, and एक statement नहीं है ना, that you focus on that statement. There are 4 statements, and each statement has true, false, true, false, true, false. So RBCs are red in color true, WBCs are white in color true. But एक गलत हो गया, 3 के बराबर आ गए, तो final answer is like TF, 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 TT. So your whole answer is messed up, right? So remember, small words. We'll be doing lot of MCQ practice. When I do only MCQ practice. How you are strict, I will show you. So RBC, WBC, and platelets. WBC are granulocytes and agranulocytes. This is beyond the scope of the book. But there are small cytoplasmic granules in some of the WBCs, okay, which stain differently, either acidophils or neutrophils. So these are granulocytes because of the presence of granules in the cytoplasm. And those WBCs which do not have granules are called as agranulocytes. Which are the granulocytes? Neutrophils, eosinophils, basophils. Which are the agranulocytes? Lymphocytes and monocytes. In lymphocytes, there are B lymphocytes and T lymphocytes. What is the difference? You'll see in human heart and diseases, in human health and diseases, chapter in West Angle. Okay? So this is the mind map of the blood. It's not given in this format, but it is exactly how they are described in the textbook. Okay? So this is, we are going to study one by one now. So plasma is simple fluid matrix. पानी है वो. Okay? 55% is plasma and 45% is formed element. Okay? So in the blood, if blood is 100 grams, 55 grams is going to be plasma and 45 grams is going to be formed element. Okay? It is straw colored, slightly viscous, slightly alkaline, pH 7.4, fluid matrix. Okay? It is the solvent, it is the fluid in which the cells are suspended, dispersed. Okay? We cannot say dissolved because cells are separate. They don't get dissolved in the plasma, but they are dispersed or suspended in the plasma. Okay? Which cells you already saw? RBC, WBC and platelets. Now coming to the plasma. These are all factual questions. I'm running through the slides. It's a factual. You have to learn all the figures from the textbook. Okay? So plasma has what? The content of the plasma, constituents of the plasma is 90 to 92% is water only. Okay? Then 6 to 8% is formed is plasma proteins. Now the 3 major plasma proteins are fibrinogen. It is a factor which is used in blood coagulation. Another is factor number 1 is fibrinogen. Okay, there are 13 factors, but factor number 1 is fibrinogen. It's not given in the book, the name of the factors. But remember, it's a very important factor for coagulation of the blood, which will come later. Globulins, these are secreted by the WBCs only, B lymphocytes. These are proteins which are secreted, which are made by the WBCs. Okay, and they are helping in defense mechanisms. Okay, our antibodies are globulins. They act as antibodies. Globulins are actually gamma globulin, alpha globulin, beta globulin. They are all antibodies. Okay, and the third protein is albumin. Albumin is made actually by the liver. It's manufactured in the liver. It enters the blood, and it is required for the blood pressure that we have, 120 by 80, and the our osmotic pressure of the body is given by the albumin, or it's also called as oncotic pressure. Okay, osmotic pressure given by albumin or proteins is called as oncotic pressure. Okay, osmotic is because of all the constituents, whether it is sodium, any solute will contribute to the osmotic pressure. But when the osmotic pressure is specifically because of the protein component of the blood, it is called as oncotic pressure. Again, beyond the book, no, don't remember. Whatever is in the slide is from the textbook. So, extra जो बोल रही हूँ वो लिखने का है तो लिखो, नहीं लिखा तो भी चलेगा. Finally, textbook हमको रखना है. Okay? So, water, plasma protein, then glucose, amino acids, lipids, cholesterol. From where this has come in the plasma? From the GIT. So I'm eating now, so what's the use of eating? It has to go in the plasma. So this is the dissolved nutrients we will call. Same thing, dissolved inorganic ions. Again from the food that we eat and from the tissues also they also create. Okay? So inorganic ions. Okay? What is the use of the glucose and the nutrients? For energy production and growth. Ions, again, regulation of osmosis. And gases. Gases, where whatever I take in oxygen by the way of breathing, it diffuses, it goes into the blood. We saw when we saw the motive of circulation, we said that gases was one of the most important uses of circulatory system. So the gases are dissolved where? In the plasma. In the plasma. CO2, especially CO2. Okay? O2 in a very small amount, because O2 is mostly bound to hemoglobin in the RBC. A very small amount of O2 will be there in the plasma. But gases like CO2, a majority of CO2 is dissolved in the plasma. Okay? And nitrogen. So this is for transport of gases. So this is the constituents of the plasma. 90 to 92% water, it's a good solvent. Then plasma protein, fibrinogen, globulin, albumin, nutrients, inorganic, ions like sodium, magnesium, chloride, bicarbonate, calcium, and gases. Now, what is serum? Plasma also has clotting factors. When we do coagulation part we will see plasma also has clotting factors. So when the clotting factors are used up to form a clot, whatever is remaining is called as serum. Okay? So how do we get serum? Just put the blood in a test tube and allow it to clot. If you get an injury and if you get the blood, okay, and you just suspend it in a test tube and you allow it to clot, okay, there will be a yellowish layer which is remaining above. A yellowish fluid-like layer which is remaining above. Okay, this is the clotted blood. Okay, and the plasma without the clotting factors. Why clotting factors are not there? Because they are here and they are used up for clotting. They used up. Clotting factors का फायदा क्या है? Clotting factors का use क्या है? For creating the clot. So whenever this clot was formed, the clotting factors were used up. So this part of plasma is depleted, or it is without the clotting factors, and this part of plasma is called as serum. So dash minus dash is equal to dash. Or one more. Plasma minus serum is equal to? Can it be that way? Plasma minus clotting factor is equal to serum. So plasma minus serum is equal to clotting factor. Same thing. But what is the logical thing is plasma minus clotting factors. When the clotting factors are used up, what is remaining is the serum. And all the tests are done on this serum. Supposing I want to do my sodium level in my blood. Okay? I'm feeling very weak. And body का sodium कम हो जाता है ना, person starts feeling very weak. Okay, it is called as hyponatremia. Okay, now I have to go to a lab and do my test on serum. What they do? They take the blood, put it in a test tube, and allow the blood to clot. So the serum separates out, and whatever serum comes out, that serum make a sodium ion is tested. Okay, or I want to see whether I have antibodies to dengue. Antibodies are going to be in the serum. Okay. Antibodies are going to be in the serum, so they will allow the blood to clot, take this part of the plasma, which is the serum, and test for antibodies. Okay? So everything, we don't want clotting factors over here. Okay? But can I test my RBC count from this? No, because some RBCs are trapped in the clot. We will see what is clot. Clot is a meshwork of fibrins with trapped elements of formed elements. Understood? So when I want to do my blood count, hemogram, I cannot allow the blood to get clotted. I have to use a bulb or a test tube which has an anticoagulant in it. So the blood will not clot and the entire blood will remain intact for me to test the blood, because I want to test only the RBC count. So serum मुझे test नहीं करना है. I don't want to test for antibodies. I want to test basically whether I have good RBC, whether I have anemia, whether I have good WBC count. Okay, so this is some applied part not given in the textbook. Coming to formed elements, RBCs, WBCs and platelets. Okay, so RBCs, red blood cells or erythrocytes, WBCs or leukocytes, and platelets or thrombocytes. This is the terminology. Coming to RBCs. Features of RBCs. Red. Blood is red due to RBC and RBC is red due to hemoglobin. So here red due to hemoglobin, the RBC is red due to hemoglobin. Normal, what is the normal hemoglobin level? Very commonly asked MCQ. It is 12 to 16 grams per 100 ml. This is one of the very rare places where the denominator is 100 ml. Remember, it's not per microliter or cubic mm or liter or anything. It is per 100 ml or deciliter. 100 ml is called as deciliter. Okay? So 12 to 16 grams per 100 ml. Lifespan is 120 days. Okay? These are factual facts. There is no much explanation to it. RBC lives for 120 days. Count is 5 to 5.5 million per cubic milliliter. Now this is per cubic milliliter of blood. Okay? Or per microliter of blood. Okay? This is the count. Where is it formed? In the red bone marrow. Now bone marrow has got two parts. A red bone marrow is in the axial skeleton, in the skull, in the vertebral column, whatever it is, the red marrow, where the formed elements are taking form. I mean, they're taking birth over there. Okay? The genesis of all the RBCs, WBCs, platelets, all of them are formed in the red bone marrow. Okay? Then structure is biconcave in shape. Can you make out something like a biconcave in shape? Okay? You learned lenses. A biconcave lens, like this. So biconcave in shape. Now, why is biconcave shape? Why do you need a biconcave shape? Okay, one reason could be because it can slide through the small capillaries very easily. One ball kaise jayega, but that's not the cause. The cause is the surface area of a biconcave disc is much more than a sphere of the same volume. Understood? Okay? If it's a sphere, you convert a sphere, take a ball, okay? Ball madhe hawa geli na, football, see, and it becomes chapta. Make it biconcave like this and calculate the surface area. The surface area of that biconcave disc is much more than that of the sphere. Understood? And why do we need surface area analysis? Because we want oxygen to come in and get bound to hemoglobin. The whole function of RBC is basically to carry oxygen, and oxygen has to come inside the cells and get bound to the hemoglobin. Okay? So, biconcave shape, no nucleus, no mitochondria, no Golgi complex. There are no organelles in the RBC. Why? Because the whole purpose, there is nothing, it is just a packet of hemoglobin. It is a cell which does not have, they don't want to waste any space for a nucleus. It does not divide, so it does not require nucleus for any cell division. Nucleus has got basically two functions. Protein synthesis, which you study in, is not done molecular basis study in protein synthesis, but cell division you have done. So the nucleus का function is दोनों functions इसमें नहीं है. RBC does not divide, it does not synthesize any protein. Okay, so it has nothing inside, but the entire thing is packed with hemoglobin. Okay, what is the function? CO2 and O2 transport. So these are the facts all given in the textbook. When you go home and read today, I will want you all to read whatever we been taught in the class. Okay, right now you all don't have too much time to do any self-study. Only whatever is taught in the class, try to go home and read. सुबह जो सिखाया है वो और जो मैंने आपने whatever 5 lectures का study, at least half an hour each. Give you at least 2.5 hours of self-study per day after going home. Just read what is done in the class. In the morning 3 lectures or afternoon 2 lectures. Okay? At least that much you all will. And you'll have to see what is required for tomorrow's lecture. That is one more task. Means, like she has not understood ionic equilibrium. So tomorrow, in order to understand whenever the next ionic equilibrium is going to be there, उसके पहले उसके lecture देखके होने चाहिए. So that you will just be with the class. Right now for this batch, our aim is just to be with the class. This खूब प्यारे नंतर. You have lots of time. One whole year is there. We will work hard. We will study. We will do the learning part and solving MCQs. Right now, just understand the concept. I don't want anyone not understood anything. You have come here because you have not been understanding them. Okay? So we are just having two motives of this batch. One, that you understand everything, and second thing is that the portion should be at par, and our entire batch, I mean the whole APMA, this batch portion will get over on the 30th of November. And last 6 months we have ample time for revision. Imagine 6 months nothing new is taught. You're only revising every day. Okay? So these are the facts of RBCs. All are given in the textbook. Go home and read. Okay? Worn out RBCs are destroyed in the spleen. So RBCs, whenever they get worn out, uska kaam ho gaya 120 days. Okay, they will go to the spleen and they get destroyed by special cells, copper cells which are present in the spleen. Okay, they do all the phagocytosis and all and remove the worn out cells. We have 10 minutes. WBCs, color is colorless, it's not white. Lifespan is around 50 days. Count is, that was 5 to 5.5 million. And this is 6,000 to 8,000 per cubic millimeter of blood formed in the bone marrow, lymph glands and spleen. Structure is nucleated. Now they have nucleus. They have organelles. Nucleus, but the nucleus is of different types. Okay. Then function, part of the immune system. Is the main thing, is to create antibodies, to create cell-mediated immunity, to create antibody-mediated immunity. So all these are the functions of the WBCs. We will study each one function in detail. Okay, but these are the common characteristic of the WBCs. 4 types, 3 granulocytes and 2 agranulocytes. So neutrophils, eosinophils, basophils, these words are not given in the textbook. Do not remember them. They are based on the staining characteristics. Okay. Neutrophils are 60 to 65%. Function is phagocytosis. What is phagocytosis? It is engulfing of, say, dead bacteria, some broken cell membrane, some element of the cell which is non-functional. So it will engulf it and then digest it with the use of using the enzymes from the ribosome. So digestive enzymes are present inside the cell. Okay, sometimes the cell itself also dies. In order to do phagocytosis function, it will itself die. Okay, so this is neutrophils are phagocytic cells. They are called as soldiers of the body. Eosinophils, this is 60 to 65%, which is number 1. 3% eosinophils. They resist infection, so they also have a role. They secrete substances which help in resisting infection. And eosinophils play a role in allergic reactions. Very important common OPC. Everything is printed in the text. Go home and read. Whatever part of the chapter we have finished, go home and read. Cause allergic reaction. Basophils, smallest type, smallest number, 0.5 to 1%. They secrete histamine, serotonin, heparin and cause inflammatory reactions. So, inflammatory reaction, inflammation is basically what you say soothe in Marathi or sujan in Hindi. Okay, swelling. Okay, this is the immune response of the body towards something that we don't like, something that is foreign. Okay, so you get a mosquito bite, you get that redness around it. Okay, you get the pimple-like thing and then you get a redness patch around it. That is inflammation. Okay, so basophils, so all of them in some way or the other participate in inflammatory reactions. But basophils secrete histamine, serotonin, heparin. These are the chemicals which are mediators of inflammation. Okay, they are mediators of inflammation. So basophils play a role in inflammatory reaction. Monocytes share the function of phagocytosis. So phagocytosis which 2 cells? Neutrophils and monocytes. Okay, one is the granulocyte, one is the agranulocyte. So tell me the agranulocyte which does phagocytosis. It is the monocyte. So such questions will be asked. Okay. Then lymphocytes, the smallest WBC but largest nucleus. Again 2 types, B lymphocytes and T lymphocytes, 20 to 25%. And immune responses of the body and secrete antibodies. Okay, why immune responses of the body? Because cell-mediated immunity, this is one type of immunity which is given by the T lymphocytes. We will study that in class 12. And B lymphocytes will give you an immunity called as antibody-mediated immunity because they secrete proteins called as antibodies. So coronavirus हो गया infection. So who is getting active? B lymphocytes, because they are creating antibodies. That's how we do the antibody test, right? Okay, for whether you've been infected now, it's obsolete. Nobody does it now. But initially, you used to do antibody titers whether you've been infected with corona or no previously. So this is the lymphocyte. So here questions are normally asked about this function, yes, and also the percentages. Match the following will come very commonly about types of cells and percentage. So this is just mugging up, okay? Okay. Another thing, this is a diagram-based question which comes in WBC. They ask you the ascending order of the sizes, considering platelets, WBC, and write down the question for me. Okay. So see, ascending order as far as number is concerned, basophils सबसे कम 0.5 to 1, then neutrophils 2 to 3, then monocytes 6 to 8, then lymphocytes 20 to 25, and then neutrophils 60 to 65. Okay, all that is given in the book. Don't worry. I'm just telling you the questions which can be asked. They'll give you all the various orders. Ascending पूछा है from least to maximum. Okay, so that according to the numbers which are given in the book, you have to arrange them. Second is diagram-based question where they have said arrange it according to the size. Size smallest क्या है? Lymphocytes. And surely what is smallest? Lymphocyte. And surely what is largest? Monocyte. Okay. The remaining three, okay, it is actually basophil, neutrophil, and then eosinophil. But the diagram here is mixed in different textbooks, so don't, and they will never ask you because the diagram is not clear. Only they will ask you which is the smallest WBC, which is the largest WBC, okay, बीच वाले actual science wise, if I tell you lymphocyte से बड़ा basophil से बड़ा neutrophil से बड़ा eosinophil, and eosinophil से बड़ा monocyte. But remaining बीच वाले three are almost all same size. Even in the book they look almost the same. Then the shape of the nucleus is one more question diagram based that they ask. So write the shape over there. Neutrophil is multi-lobe. Eosinophil is bilobed. No. Basophil is S-shaped. Monocyte is bean-shaped. And lymphocyte is a large rounded nucleus in the lymphocyte. Okay? So 4 types of questions come. First, bean shape is monocyte. क्या हुआ? Okay. Neutrophil is multilobed. Eosinophil is bilobed. Basophil is, sometimes they say twisted or sometimes they say S-shaped. But Truman has said S-shaped. Monocyte is bean-shaped and lymphocyte is rounded. So 4 types of functions, 1, 2, 3, 4 I'm telling you. First is number of WBCs पे question है. Second is function of WBCs पे question है. Third is size of WBC, size of the entire cell. And fourth is shape of the nucleus. Okay, shape of the nucleus. Understood these 4 kinds of questions? Okay. Now we just quickly do platelets in 5 minutes and then we'll stop. Platelets, they are not actually root cells. They are fragments of cells called as megakaryocytes. Okay, the word is not given in the textbook, so whatever is in the textbook I'm stressing again and again. But there are some cells called as megakaryocytes in the bone marrow. Okay, and the megakaryocytes are the precursor cells of the platelets. So megakaryocytes are made in the bone marrow. Again, which marrow? Red marrow. Yellow marrow is just fat. Okay. There is a bone marrow. People who eat non-veg, you know, if you see the mutton bone, There is marrow inside the mutton bone. Have you seen it? Okay, that is yellow marrow. It is not red marrow because it limbs mein. Okay, so color is colorless, platelet. Lifespan is only 7 days. Count is 1.5 to 3.5 lakhs per cubic millimeter of blood. All the counts, RBC, WBC and platelets are per cubic mm of blood, and hemoglobin is per 100 ml of blood. Okay, formed in the megakaryocytes in the bone marrow. So megakaryocytes, they come out of the bone marrow and small pieces are broken of the megakaryocytes, and these are actually the platelets. Structure, again non-nucleated cell fragments. Function, blood clotting. Okay, there are certain factors which initiate blood clotting. Okay, so this is about platelets. So next topic we will be doing is coagulation of blood. Can we do it next time? Too much saturation now. 12 minutes at least, 20 minutes break. 5 minutes to 3:15 while we start the next and the last lecture. Nasu sir will be taking today actually. Yeah? He was a very good teacher to pay attention and get most of it. Okay. Tell me any doubt in whatever we taught today. We just quickly revise. I like to revise quickly in 3-4 minutes, 2-3 minutes only what we did. We started first with the motive why we need circulation. Any doubts in that? Okay. Second, we said that circulatory system is getting evolved from the lowermost phylum to the highermost phylum. Okay. In the simplest phyla like sponges like Porifera and Ciliate, we have simple diffusion. It's like a sponge, kitchen ka sponge. Pani mein dalo, pani andar aa jata. Okay. Then as and when we get more involved, first open circulatory system and then close. Okay. Cockroach, Annelida, mollusca mein open. Open mein heart and no blood vessel. There's only one vessel which just leaves the, like a hole, which just leaves the blood out into a complete big cavity called the hemocoel. All organs based in the hemocoel take whatever they want, they take from there. Whatever they don't want, they leave in that in the hemocoel. Closed system mein well coordinated. You are not allowed to go out only. The heart, the vessels, small करके capillaries will almost touch the cell and stop there. Okay, so blood is enclosed in the circulatory system, in the blood vessels. Blood vessels is a key part of the closed circulatory system. Then coming to blood itself. Okay, last before that circulation, 3 kinds. Double circulation, single, incomplete circulation. Double circulation starts with the tissues, ends with the tissues, but there are 2 circulations like this. Okay, so from the systemic veins to the heart, from the heart leaves the pulmonary artery to the lungs, from the lungs the pulmonary vein to the heart, and from the heart again the systemic artery back to the tissue. Okay, this is double circulation which requires a four-chambered heart. Single circulation seen in fish, double circulation seen in crocodile, bird, mammal. Single circulation seen in fish. Fish may, from the tissues, deoxygenated blood goes to the heart. Deoxygenated blood itself leaves the heart, goes to the gills. Gills is the oxygenating organ, the blood gets oxygenated. Then oxygenated blood will leave the gills and go to the tissue. So one single circuit. Okay? So it's like a pumping station, it's like a gas filling station. You go here empty, you stop at the gills, get your refill and go for the forward journey. Okay? Incomplete double. Right side में deoxygenated blood, left side में oxygenated blood. Both come in the ventricle, get mixed. And the mixed blood will then leave the heart. And again go to the lungs for oxygenation again. And for supply to the tissue. Then coming to blood per se, blood itself. Blood has got plasma, formed elements. Plasma में mostly water, clotting factors. Then there are nutrients, glucose, there are electrolytes, and there are coagulation factors. And dissolved gas. Formed elements, RBCs, WBCs, platelets. RBCs are red blood cells. Most important cells because they are the carriers of oxygen and they have hemoglobin which is going to carry the oxygen. WBCs are all defense वाला. आगे पीछे all the functions are related to defense only. Different words are there. Immune reaction, allergic reaction, but everything is about immune response. Okay? 5 types, granulocytes 3 and granulocytes 2. We discussed number is important, function is important, shape of nucleus is important, and size is important. And that's the statement. Clear? Okay? Go home and read this part. It will just take 5-7 minutes to read it. But read it today. Mark the important things. Okay? Next time random questions I'll ask. For first 2-3 minutes. Simple. I'll just say, tell me. Simple, like simple, no? Fire. So fire, tell me what is WBC count. 6,000 to 8,000 per cubic millimeter of blood. That's how much percentage is you know. So she has to tell. Okay? Yeah. So whatever, how much of our part we have done, so इसमें ही हमारी पढ़ाई. अभी इसमें ही पढ़ाई है, इसमें ही पढ़ते पढ़ते हमको आगे जाना. Maybe I will go because the normal batch is very lenient. Ask her. They don't study. It's like very casual now because आराम से चल रहा है. It's a comforted life. Come to attend the class, go home, eat, drink. Next day come for the class. Whenever there's a test, study, give the test. But maybe now we have a plan. We have focus. We all will be ahead of them. I'm sure you all will. Okay? Chalo. See you all.